An algorithm is a set of step-by-step instructions or a procedure for solving a problem or performing a task. It is a well-defined computational procedure that takes an input or a set of inputs, performs a series of operations on the inputs, and produces an output or a result. Algorithms are used in many fields, including computer science, mathematics, engineering, and science. They can be used to solve problems such as sorting a list of numbers, searching for a particular item in a database, or finding the shortest path between 2 points on a map. Algorithms are typically designed to be efficient, accurate, and reliable. They can be expressed in a variety of forms, including pseudocode, flowcharts, or programming languages. Once an algorithm has been designed, it can be implemented in software or hardware to automate a task or solve a problem. Some common examples of algorithms include sorting algorithms. These are used to arrange a list of items in a particular order, such as alphabetical or numerical order. Searching algorithms. These are used to find a specific item in a list or database. Encryption algorithms. These are used to encode or scramble data to protect it from unauthorized access. Optimization algorithms. These are used to find the best possible solution to a problem, such as minimizing the cost of a production process or maximizing the efficiency of a transportation network. Overall, algorithms are a fundamental concept in computer science and other fields, and they are used to automate tasks and solve problems in a wide range of applications. What are the characteristics of an algorithm? Clear and unambiguous. The algorithm should be clear and unambiguous. Each of its steps should be clear in all aspects and must lead to only one meaning. Well-defined inputs. If an algorithm says to take inputs, it should be well-defined inputs. It may or may not take input. Well-defined outputs. The algorithm must clearly define what output will be yielded, and it should be well-defined as well. It should produce at least one output. Finiteness. The algorithm must be finite, i.e., it should terminate after a finite time. Feasible. The algorithm must be simple, generic, and practical, such that it can be executed with the available resources. It must not contain some future technology or anything. Language independent. The algorithm designed must be language independent, i.e., it must be just plain instructions that can be implemented in any language, and yet the output will be the same, as expected. Input. An algorithm has 0 or more inputs. Each that contains a fundamental operator must accept 0 or more inputs. Output. An algorithm produces at least one output. Every instruction that contains a fundamental operator must accept 0 or more inputs. Definiteness. All instructions in an algorithm must be unambiguous, precise, and easy to interpret. By referring to any of the instructions in an algorithm, one can clearly understand what is to be done. Every fundamental operator in instruction must be defined without any ambiguity. Finiteness. An algorithm must terminate after a finite number of steps in all test cases. Every instruction which contains a fundamental operator must be terminated within a finite amount of time. Infinite loops are recursive functions without base conditions do not possess finiteness. Effectiveness. An algorithm must be developed by using very basic, simple, and feasible operations so that one can trace it out by using just paper and pencil.